We're going to look at logarithms today. We're going to talk about how to convert logarithms, how to find their inverses. We're also going to talk about how to simplify and evaluate logarithms without using a calculator for the most part. Now, don't get me wrong, calculators are allowed. I'm not telling you you can't use them, but you don't need to use them. So if you find yourself trying to type in log of something and working it out, and it's not happening for you, that's not going to happen. It doesn't work like that. So we're going to look at, let's look at number 2. It says log base 6 of 1 over 36. Now, this is really not the hard part. Here's a technique that you can use all the time. If I want to evaluate something now, a lot of this you're going to get to a habit where you think, oh, I can actually see the answer before we even get started. And most of these problems, you're going to figure that out really quick. And here's the thought process that you should begin to go through in your head when you think about problems like this. What we're going to do is we're going to take that object that we're taking the log of, and I want to rewrite that as a power of the base. So can you rewrite 1 over 36? That's really 1 over 6 squared, right? And if I rewrite that, I want it to be 6 to a power. So it would be 6 to the negative 2. And so, and this is the long version, but this is what we're doing. When you have this happen, log base 6 of 6 to the negative 2, the question's saying, what do I raise 6 to a power of to make it become 6 to the negative 2? And it's like, isn't that what you just said? Okay, the answer is negative 2. Those kind of just cancel out.
When there's one
it works both ways.
No. That wasn't what I was even talking about.
Sorry, go ahead.
You said that when you have a negative exponent, it doesn't matter, it's going to turn in positive.
That's not what we're not actually raising it to an exponent.
Oh.
We want to know what is the exponent. And negative 2 is your exponent. Try number 4. Let's look at 4. Shh. Pay attention. Number 4, you have log base 3 of 81. So the question is, what is 81 is what power of 3? That's another way of looking at this problem. Let's just write it out. Really, 81 is equal to 3 to the 4th power. And there you go. What power of 3 is 81? That's really the question the log is asking. Look at 6.
Mr. Wigg,
Ma'am?
like on number 2, where those canceled out, all the fraction ones, will they cancel out?
What is it?
Well, if you write it the same way we did, yeah, that's the point. But, yeah, and to answer your question, yes, it would.
Wait.
You've got to write it that way first, though. Look at number 6 and try that one. Well, let's just look at 6. What's the answer to 6? It's 2. Piece of cake. 6 squared is 36. Let's look at number 10. We have log base 4 of 16. 4 to what power is 16? It's 2. Not really complicated. Now there's a different kind is number 12. Look at 12. What happens to this one? You have log base 4 of 1. I did one like this yesterday. I said, if you ever take the log of 1, doesn't matter what the base is, the answer is always the same thing. What is it? You're right. It's 0. Because 4 to what power is 1? Anything to the 0 power is 1. So that's a kind of a key phrase. If you see that 1, if you see you're taking the log of a value like that, of 1, doesn't matter the base, the answer is 0. Always. Look at number 18. We have log base 7 of 1 over 49.
Wouldn't that just be negative 2 again?
It would.
So all the fraction ones are going to be negative 2.
If you're taking the log of a fraction, it should end up being a negative answer. Okay, I'm not going to say always, but it most likely will. The reasoning here is because 1 over 49 is equal to 7 to the negative 2. And that's what your answer is.
What was 12?
0. It's on the screen. Try number 20. Log base 3 of 1 over 243.
Okay, wait, I have a question.
Shh. What, let's answer this question. What is 243 a power? What's the power?
5, so it'd be negative 5.
So, right. So 3 to the negative 5 equals 243, or 1 over 243.
I don't think this calculator would.
So 1 over negative 5 is the answer. We're going to talk about finding the inverse of a log function. Let's look at number 24. We have y equals log base 3 of x to the 4th power. Okay?
Switch X and Y.
Ooh, do not jump the gun. You can't go directly to switching x and y because you're going to run into the problem of that log. You're going to have to know something first. We're going to do that. We are going to switch x and y, but we must convert into exponential form first. Okay? So,
Can you do the little thingy where you like name it off going across so you know what word to put it in?
I'm not sure what you're talking about.
What's the little thingy on the
Okay, last year when it would be like this, there were like letters above it, and how it would be like this, and then how it would be in exponential form.
Okay. So try this one. If we had like y equals log b of x to the a, like that.
Yeah, I'll write the other one.
So this let's just go like this. So this would be b to the y would equal x.
That's inverse?
Well, this is how you convert back to power, to the exponential. So let's change this. In order for me to work this out properly, we're going to do one thing first. It's y equals, if you have a power, see how the 4 is a power? I'm going to bring that power out front. It's going to be here, 4 times log of 3 to the x. Right. I would have made that switch in a minute, but I'm going to bring it out front. Before we can switch to exponential, this is key. This is important. This is where most people are going to mess up. You're going to need to get it to log equals some number. So the first thing we do is divide by 4. Once I divide by 4, you have y over 4.
There's no 4 in the equation.
Is this supposed to be number 25?
24.
There's no 4.
It's the exponent of x.
Wait, but that's not the same equation.
Did I mess up?
Yeah, it says log 3 x.
That's right. Shh. Look, right here.
Yeah.
Shh, shh. Listen carefully. Back up a minute. In order to do this, I want to take the exponent of what I'm taking the log of, and I bring that exponent out front to get 4 log base 3 of x. I want to get the log isolated. So we're going to divide both sides by 4 first. And then we have y over 4 equals log base 3 of x. So here's what happens next. We convert from this form to its exponential form. So what we're going to do is we're going to take this and raise it to that power, and it's going to equal that value.
What?
I'll show you. It's going to be 3 to the y over 4 equals x. So you take the base, raise it to the other side, whatever's on the other side, and it's going to be equal to whatever you were taking the log of. It's just like this up here. B to the y equals the x. And now I switch x and y and simplify if I need to. So this is going to give me 3 to the x over 4 equals y. And that's your inverse. This is tricky, but once you get the process down, it won't be hard. And that one's probably one of the harder ones. Okay, it definitely gets easier than that. You have a lot less steps to do sometimes.
Wait, how did you just switch x and y back?
The very last, well, when you go from logarithmic, you convert to exponential. The next step is to switch x and y. Let's do another one. Let's do number 26. So 26, you're going to be y equals, listen, log of 1/5 of x plus 7. Do I have to do anything prior to getting it isolated to the log?
Subtract 7?
No. Look, this is a big deal. That plus 7 is inside the logarithm, correct? Yes? I can't do anything to it yet. So, because there's nothing outside to get away from the log, I go directly to switching to exponential form. So it's going to be the base raised to the y equals whatever we're taking the log of.
Where'd you get that? Oh, it looks like 15.
Sorry, it's 1/5. That's really hard to write.
It's like 105.
Yeah. You mean write it traditionally?
1/5 y.
There we go.
Oh, that's cute.
Is it to the y? Or
Yes, this is to the y right here.
But why?
You remember, you take You take this object and raise it to that power, and it's going to be equal to whatever you're taking the log of. Now, I'm not quite finished yet. What's the step after switching to exponential? Switch x and y. So now we have 1.
1/5 to the x. Y plus 7.
And the last step was what? It's 1/5 to the x minus 7 equals y, and that's your log, or your exponential inverse. I want you to try, flip the page over, and I want you to try the next couple. One thing to note, on number, no, let me go over that. Number 28, please listen. On 28, you have y equals the natural log of x plus 2. Let me make a note about the natural log. The natural log of x is the same thing as saying log base e of x. If you want to write log with a base e, or if you just want to write in right here that there's a base of e, you're more than welcome to make those changes.
So ln is e.
ln has a base e. So when you go raising it to a power, it's going to be e to some power.
E to the y.
Exactly.
E to the y. E to the y.
Is this one right?
Here we go. Number 28. Listen, please. 28 says, we're going to go ahead and, let me erase that part.
Mr. Wig, 28 is an Ellen.
It is. It's a natural log. So, be careful. Do I convert or do I subtract 2 first?
Subtract 2.
No, you don't subtract 2.
I subtract 2.
Why? You just told us to just not do that.
No, that's a good question. Is the 2, look at the equation. Is that a part of the log or is it outside of the log? It's outside the log. The goal is to get the log isolated. So you put the 2 on the other side.
What's ln?
So minus 2 is the natural log as a base of
So
e.
is that as a base of e?
Yes. So y minus 2 equals the natural log of x. Remember, there's a base e. So now we're going to raise it to the power, convert it to exponential. So it's going to be e to the y minus 2 equals x. Switch x and y and you're done. E to the x minus 2 equals y. This is a little weird, but you just need to get used to seeing the patterns change, right, Griffin? Okay?
Team sleep.
Shh. All right. I want you to try the next. 30 is y equals log base 1/5. Let's see. And it's x plus 6. We are going to subtract. Shh, listen. We're going to subtract 6 first. Shh. We're going to have y minus 6 equals. Why did we subtract 6 there?
It's not part of the log.
Right, it's not part of the log. Subtract it first. Now we're going to turn it to exponential form. That's going to be 1/5 raised to the y minus 6 equals x. So I forgot my x there. Now you switch. So you're going to have 1/5 to the x minus 6 equals y. 32. No, once you get the hang of this, it's kind of the same. Once you get it, you get it. And it's the same thing a million times over.
Wait a minute.
Yes, ma'am.
Somebody's falling behind.
Shh.
No.
Go ahead.
Why is that minus 6 up at the top?
Hold your thought. I'm going to do this one. And then I want you to look at the differences between the two, and I think you'll understand.
Because, like, the bottom, it's in the, like,
I know.
1/5 x minus 7.
Let's do this one and then look at it, and I think you'll get it. Shh. So look up at 32. Shh. We're almost out of time. Look up at number 32.
Can you grade it right now?
No.
Like today.
I'll just say. Do I go ahead and convert to exponential, or do I need to do some adding and subtracting here?
You could go ahead and convert to exponential because it's going to go
It's a logarithm equal to y. So we're going to convert 4 to the y equals x minus 6. Now I have to go ahead and simplify. It's going to be 4 to the x equals y minus 6.
Can you do
Yes,
38?
sure. 4 to the x minus 6 equals y. Do you see the differences? See how this one had a plus 6 out beside it on 38, on number 30? But number 32, it was inside the logarithm. If you look at the final answers, if it's outside the log, it's going to be in the exponent of the other one. If it's inside the log, it's going to be outside of the exponent on the finished product. It's just the opposite of what you would naturally think it would be. That's fine. You said 38, Megan?
Yeah.
38, shh, listen please. You have y equals log base 3 of negative 3x. Well, this goes straight to the point. Shh, listen. It's 3 to the y equals negative 3x. So switch x and y. So you have 3x equals negative 3y. What are we going to do now? Divide by negative 3. And so you're going to have... Be careful about this one because you can simplify this probably a little bit more than you think. So what is 3 to the x over negative 3? Can I simplify that one side any? Isn't that 3 to the first power? So what do I do when I simplify? That's obviously going to be negative something. Negative 3 to the x minus 1 equals y. I subtracted their exponents. The negative sign I left out front, that's like negative 1 times everything. And so you left it there, and you have negative 3 to the x minus 1.